So what we're going to do is we're going to speed run through 5.3 and 5.4.
Okay.
All right, so we have 5.3. This is graphing. Mainly, yeah, we did, this class did, yeah, but I got to make a video. All right, so graphing, mainly dealing with transformations. So I'm not going to ask you to graph these functions, which is fine, so ignore those directions. But what I want you to do with these 6 problems is state the transformation, and then determine the domain and range. I don't care about increasing or decreasing, so we're good there. So state the transformation, and then what are the domain and range. Before I get into that, though, I want to take a look at these 2 parent functions, right? So y equals root x. That is a graph that looks like an eyebrow that starts at the origin. So the domain for this graph is 0 to infinity, right? As we scan left to right, the smallest x value is 0, the largest is infinity. The range as well, 0 to infinity. The smallest y value is 0, the largest is infinity. So that's the first parent function. The second parent function is the cube root of x. Notice that this 3 tells me, all that 3 tells me is the shape of the graph. That is not a transformation. It's not a multiplier. It's the index. And that is Snake River on its side. So there we go. Boop, boop. All right, domain, all real numbers. Range, all real numbers. That's negative infinity to infinity for both the domain and the range. So what happens with our transformations, and how does that impact our domain and our range? So problem 32. We did this yesterday, right?
Yeah.
So we should have some pretty quick answers. Mm-hmm. All right, Colton, how many transformations does 32 have? 1. Name that transformation. So down 1 unit. Good. Is that the square root or the cube root? That's the square root. And if I take that graph, shift it down 1 unit, does that impact the domain? No. So the domain is still 0 to infinity. And these are brackets. What then, Colton W. Smith, is the range? Pretty good. -1 to infinity. All right. 32. Emmett, how many transformations do you see on 32? No, we just did 32. Stevens? 33. 1. And what is that transformation? We're going up 2 units. And the domain and range are going to be what, Emmett?
Domain?
Yeah.
Negative infinity to positive infinity.
Good. All real numbers. Negative infinity to positive infinity. Range, Emmett?
Range is negative infinity to...
Oh, don't get stuck there, big dog.
Oh, what?
All real numbers. Yeah, so while you were playing on your phone, I said the domain and range for all cube root functions is all real numbers. Yeah. As the kids say, clocked all your T there, big dog. Clocking it.
Never.
I clocked your T, sweetie. Here we go! Connor, 34. How many transformations do you see? Name them.
Stretch by 1/2.
Easy.
Or compress
Yeah, we're going to compress by 1/2. What's the other one?
to the left.
Yes, good. Left. 1 unit. Emmett is 34. Emmett, is that a square root or a cube root?
Square.
Square root. Good. And if we compress it and shift it left 1 unit, what's the domain, Emmett?
It'll be
Awful.
-1 to infinity.
Good. -1 to infinity. What is the range, Emmett?
0 to infinity.
Good. Good job. All right. 35. Elvis, how many transformations do you see on 35?
2.
Good. Name one.
Stretch.
That is a stretch of 2. Good. If you multiply me by a half, I get smaller. If you multiply me by 2, I get bigger. So that is a stretch of 2. What's the other transformation there, Elvis?
Down 1.
Down 1 unit. Good job. What's the domain?
Negative infinity to infinity.
Why is that true? And it's not true on 34. Why is this? Because it's a cube root. Yep, all real numbers for both the domain and the range. Good job. 36. Trin, how many transformations do you see on 36? Good. What is that transformation?
Right 3.
Right 3. Good job. And the domain?
Negative infinity to infinity.
Yes. Good job. Negative infinity to infinity. The range?
Negative infinity to infinity.
Really good job. That's true because we're dealing with a cube root, not a square root. All right, 37. We have Marissa. How many transformations? Hey,
2.
thank you. And what are those transformations?
Left 4 and down 2.
Left 4 units. Good. Down 2 units. Good. Domain?
Negative 4 to infinity.
Great job, dog. Yes. And the range?
Negative 2 to infinity.
And that is a bracket. Those are included. That point exists. They are included. You couldn't even see it? My bad, dog. Hey, my bad. It's going too fast. I wasn't paying attention to the production value of this video. And for the internet's, I'm sorry. Yeah, you may. Fill out a potty pass. Tell your mom.
You make me pass.
No! Make your own dang pass. Biscuits. Here we go, 5-4. We are solving equations, right? Solving radical equations. We have to isolate the radical and then raise both sides to the power of the index. So, here we go. Did we do this yesterday in class?
Yes.
Good. I'm going to speed run it. We have problem number 40. We're looking at the cube root of x minus 2 equals 7. All right, so I need to isolate the radical. There's not a number in front being multiplied, but there is a number after being added or subtracted. So I want to get rid of him, and the opposite of subtraction is addition. So the cube root of x equals 9. Now I have to raise both sides to the power of the index. My index here is a 3, so I make the exponent a 3. The cube root of something cubed is itself, and 9 to the third is 81 times 3. 8 times 3 is 24, so 249? 229? No. It would be 729. 8 times 9 is 72. I got 8 times 4 for some dumb reason. That's 8 times 9. Yeah, that's 729. You read your 7 as a 2, didn't you?
Oh, yeah.
Me too. I do that often. I do that way too often. All right. Keep it cruising. All right, problem 41. We have the square root of 2x. That's equal to 12. All right, so there's not a number in front being multiplied. There's no number after being added or subtracted. So my radical is isolated. Maddox, what is the index of a naked radical, bud? 2. So I'm going to square both sides. The square and the square root cancel. We're left with 2x equals everybody's favorite square, 144. Divide both sides by 2, so x is equal to 14 divided by 2 is 7, 4 divided by 2 is 2, so 72 must be my answer. Oh, again, I'm not even on camera. My production value is very low today. I apologize to the 12 people that have to watch that. 42. We have the square root of 25 plus x plus 5 equals 9. All right, I don't have anything in front of the radical multiplying, but I do have a 5 being added afterwards. So subtract 5 from both sides. We get the square root of 25 plus x is all equal to 4. Then we square both sides. So 25 plus x equals 16. After subtracting 25 from both sides, x is equal to negative 9, which is not proper Spanish for negative 9.
Negative 9.
Yeah. I think it's 9 de la negativo. That's what I think it actually is, but it feels like a mouthful just to say negative 9. All right, 43. 13 minus the cube root of x. Oh, no, that's a fourth root. My bad. Is equal to 10. All right. I have a number out front over here that I have to get rid of, right? That's a positive 13. So 13 minus something equals 10. And if I really think about this, I put my finger over that. Whatever that number is, it better be 3, right? 13 minus 3 is equal to 10. So in this process, once I get this by itself, I hope that it's equal to 3. So subtracting the 13 from both sides, we get negative fourth root of x is equal to a negative 3. And when I divide by negative 1 to get rid of the negative, I have the fourth root of x is equal to 3. And that is exactly what we wanted, right? 13 minus 3 is 10. That guy must be 3. So we square both sides. Pew, pew. No. What should that exponent be? 4. Thank you. Raise it to the fourth power. And so the fourth root and the fourth power cancel. We're left with x equals. All right, so 3 times itself 4 times. We have 9 times 9 to get 81. Okie dokie, 44. We have the square root. 5x plus 1 equals x. So yesterday, somebody said x is already solved for. Are we done? The problem is that there's another x involved, so that's a little bit more complicated. So here we have to subtract the 1 from both sides. So the square root of 5x plus 1 is equal to x minus 1. Raise both sides to the power of the index, so we're going to square both sides, and we get 5x plus 1 is now equal to, here we have to FOIL, right? X minus 1 times x minus 1, and the shortcut says x squared minus 2x plus 1. Subtracting 5x and 1 from both sides, because this is a quadratic and we need to get it set equal to 0, leaves us with x squared minus 7x, and that's gone. Now that I have a quadratic set equal to 0, we're going to factor. I don't have a c term. So I have an a and a b but no c. So that means I have an x squared and an x. I can factor an x out. Left with x minus 7. So that tells me that x is equal to 0, or x minus 7 is equal to 0. Adding 7 to both sides. That tells us that we have 2 solutions, 0 and 7. Now if I plug 0 back in, 5 times 0 is 0. The square root of 1 is 1, and 1 plus 1 is 2. Well, x cannot equal 0 and 2 at the same time, so this guy is extraneous. If I plug a 7 in here, 35 plus 1 is 36. The square root of 36 is 6. 6 plus 1 is 7, and that absolutely equals 7. So that one's good. Let's go 45. We have the square root of 6x minus 20 minus x equals negative 6. All right, so I got to get rid of that x, right, to get that radical by itself. So we add x to both sides, and the square root of 6x minus 20 is equal to x minus 6. When I square both sides, we get 6x minus 20 is equal to x squared minus 12x plus 36. Get this thing equal to 0, so we subtract the 6x and add 20. Subtract the 6x and add 20. 0 now equals x squared minus 18x plus 56. Gross. All right, so factors of 56. Boy. So 1 and 56. 2 and 28, 3 no, 4 and 14, 5 no, 6 no, 7 and 8. And since 8's on the right hand side, I can stop counting. So I have to get 18 in the middle. 7 plus 8 is 15, so that's not quite 18. And 7 minus 8, or 8 minus 7, that's 1. So that would only produce a 15 and a 1. 4 and 14, well 14 minus 4 is 10, but 14 plus 4 is 18. So that tells me I'm going to use the 4 and the 14. And the only thing that multiplies to x squared is x and x. Same sign, both negative. Now that factor set works. So x minus 4 equal to 0 and x minus 14 equal to 0. So x must equal 4 or 14. Now again, when it comes to these problems, we want to check our answers, right? So if I plug a 4 into this thing, 6 times 4 is 24, minus 20 is 4. The square root of 4 is 2. 2 minus 4 is negative 2, not negative 6. So that means this guy must be extraneous. I'd plug 14 in there, but I don't know what 6 times 14 is, so I'm just going to assume that it's right. All right. Moving on. No, that was it. 5, 3, 5, 4. Sweet. Congratulations, we did it.